Hello children, your Vanashi ma'am is back with your linear inequations. Okay, now here you have already done smaller classes, simple equations, simple linear equations. So it is similar to that. Only thing is, instead of equal to sign, there will be an inequality sign. Inequality means less than, greater than, less than or equal to, greater than or equal to. These are called inequalities. A simple equal to is called equality sign. So in those equations, linear equations, you had one left hand side part of the equation, right hand side part of the equation, and both were joined by an equality sign. Here the left hand side and the right hand side of the equation will be connected by an inequality, maybe this, or greater than or equal to, or less than, or less than or equal to, and then you will have the right hand side. Okay, so that is why these are called linear inequations, because there is inequality. Okay, so now now the rules for solving the linear inequations are similar to the rules of the simple equations. Means what? When you send a positive quantity from left hand to right hand or right hand to left hand, it becomes, the sign changes. Whereas same thing in equations, same thing in linear equations. Only in case of division the rule is little different. Okay, see, let me refer to the rule, repeat the rules again. The rules are similar, so only some rules are different. Now first rule, as I told you, when you transfer a positive term from one side of the equation to the other side, the sign of the term changes. Positive to negative it becomes. Okay, so this is similar to your linear equations also. So when you change it from, when you shift the term from, transfer the term from left hand side to right hand side, when you transfer the term to left hand side to right hand side, or right hand to left hand side, positive number becomes negative. Rule 2, same thing, when you transfer a negative number from left hand side to right hand side or right hand side to left hand side, the sign changes, that is negative becomes positive. So left side to right hand side to left hand side, if you transferring, negative terms becomes positive. Okay, this is also similar to your linear equations. Then rule 3, if each term of an inequation is multiplied or divided by the same positive number, sign of the inequality remains same. Now when you multiply or divide by a, this is also your same rule as equations, linear equations. When you multiply or divide by a positive number, both the sides, left hand side and right hand side, the sign of the inequality remains same. Now the only difference, so now when you multiply, as I told you, whether left hand side is multiplied by a positive number, and if the right hand side is also multiplied by the same positive number, then the inequality does not change. Whatever is the inequality, it remains same. But now the next, if each term is on the, if each side of the inequation is multiplied or divided by the negative number, this is a positive number, when you multiply or divide by a positive number, the inequality remains same. But when you multiply or divide the any side or both the sides of the inequation by a negative number, the inequality sign gets reversed. Inequality sign gets reversed means If it is less than, it becomes greater than. If it is greater than, it becomes less than. Okay, or less than or equal to becomes greater than or equal to. Greater than or equal to becomes less than or equal to. So when there is a change in rule, this rule is not there in simple equations, but only in linear inequation when you are dividing by a negative number. Okay, so then the inequality reverses. So dividing by a negative number results in what? Results in reversing the inequality sign. Reverting the inequality sign means if greater than is there, it will become less than. If less than is there, it will become greater than. Or greater than or equal to is there, it will become less than or equal to. And if it is less than or equal to, it will become greater than or equal to. That is called reversing of the inequality. Now, the next rule, if sign of each term on both the sides of an equation is changed, the sign of inequality gets reversed. Sign is changed means, suppose minus, for example, this unless I give you an example you will not understand. Suppose you have minus x is greater than 5. So you want to know the value of x. So that means x is less than minus 5. Means what? Actually, in order to get the value of x, you are multiplying by minus or dividing by minus. Okay, you are dividing by minus 1 actually. So whenever you divide by a negative number, as per the rule, the inequality reverses. So x is greater than 5, minus x greater than 5 becomes x is less than minus 5. Did you follow this? This is very important. This is where we tend to make mistakes. So if the variable has a negative number and you want the positive number, means what? You are reversing the sign. So if you want to reverse the sign of the variable, then, or if you want to change the sign of the variable, then the inequality gets reversed. Minus x to plus x you want, inequality gets reversed. But why it is actually not a new rule? It is the same rule. Here, in order to get x, you are dividing by minus 1. So you have to divide both sides by minus 1. When you divide by a negative number, the previous rule which you have learned just now, you have learned that the inequality reverses. So minus x divided by minus 1, inequality gets reversed, becomes less than 5 divided by minus 1. So x is less than minus 5. That is how it happens. So basically, whenever you divide by a negative number, then the inequality gets reversed. Okay, whenever you multiply or divide, not only divide, you are multiplying. Suppose minus x, you want x, you have to multiply it by minus 1. Okay, you have to divide by, you have to either multiply by minus 1 or divide by minus 1. So then only you will get plus x. So whenever you divide or multiply by a negative number, the inequality gets reversed. Actually, this is also this is following the previous rule only. So basically, the main rule is that whenever you divide or multiply by a negative number, the inequality reverses. Otherwise, all the rules are same. Whenever you add, subtract, there is nothing change. Whenever you transpose, that is, whenever you transfer one term from the other side, from one side to the other side of the inequality, the sign changes. Plus becomes minus, minus becomes plus. That same rule applies in simple equation as well as in linear inequation. Whenever you multiply or divide by a positive number, value does not change, the inequality sign does not change. If you divide or multiply both sides by a positive number, multiply or divide both sides by a positive number. But if you have to multiply or divide by a negative number, when you multiply or divide by a negative number, only then the inequality gets reversed. Okay, so is it clear? This is the only new rule that you are applying in this chapter, learning in this chapter. So what is the rule? When you multiply or divide by a negative number, the inequality, negative number, where you are multiplying, dividing what? The both the parts, left hand side and right hand side. When you multiply or divide by a negative number, the left hand side and the right hand side of the inequation, the inequality reverses. The inequality reverses. Okay, so when you multiply or divide, so same example, when I am telling you minus x is say less than 5. So here, in order to get plus x, you have to multiply or divide by minus 1. So this becomes x multiplied by minus 1. And here also you have to multiply by minus 1. So inequality sign reverses. So what is the result? Minus 1 into minus x is x. X is greater than 5 into minus 1 is minus 5. So minus x less than 5 implies x is greater than minus 5. Okay. Or suppose you have minus 2x is greater than say 12. So in order to get x, you have to divide by minus 2. So if either divide, yes, you have to divide only. You have to multiply, there is no use. If you have to divide by minus 2. So this implies, when you divide this by minus 2, it becomes x. The sign gets reversed, 12 upon minus 2. So that means x is less than minus 6. Is it clear, children? This is the only new rule that you are going to apply in this chapter. Otherwise, the same rules of simple equations you will be applying. Is it clear, children? So now when we solve some sums, it will be more clear to you. Okay, children, let us do question number 3 in your first exercise. The question number 3 says a x belongs to natural number. So this x belongs to natural number. So here it will be told x belongs to which set of numbers. So the answer should be such that answer also, if x should belong to natural number, so answer means what value of x you are finding, solving for x. So the solution set also must belong to natural number. So it cannot have negative numbers. The value of x cannot be negative because natural numbers do not have negative integers, right? So x belongs to natural number. Find the solution set. There are two sub questions. You observe first how I am doing what I am, then you will be able to do on your own. So if x belongs to natural number, find the solution of the following inequations. The first sub question is 5x plus 3. This is actually a warm-up question as per your level, but since we are introducing, I'm just doing for your understanding. Okay, so now you have to bring all the variables, that is while x comes to the left hand side, and take all the constants to the right hand side. That is what we do even in simple linear equation. So the next step will be 5x plus 2x, when it comes this side to become minus 2x. 18 plus 3 when it goes that side to become minus. Here neither we are multiplying nor dividing by negative number. We are only transferring a positive number from this side to that side. So positive number becomes negative when it. So plus 3 when you are transferring from left hand side to right hand side becomes minus 3. Plus 2x when you are transferring from right hand side to left hand side becomes minus 2x. But that's all. That is the rule we are applying. That's all. We are not doing multiplying or dividing by any negative number here. So this implies 5x minus 2x is 3x. 3x is less than or equal to 18 minus 3 is 15. So implies x is less than or equal to 15 upon 3. Here you are dividing by a positive number, so there is no reversal of the inequality. So implies x is less than or equal to 5. So that means what are all the values of x? Less than or equal to 5 means in natural number system less than or equal to 5. So 5 is also included. So x will be, the solution set will have 1. Natural numbers begin with 1. Natural numbers are counting numbers. It does not have 0. Whole number, set of whole numbers. If x belongs to W, then 0 also would have been one of the elements. But since the natural number does not start with 0, the natural number starts with 1. So x, the value of x will be 1, 2, 3, 4, even 5. If it is x is less than 5, then 5 wouldn't have been there. But since it is less than or equal to 5, so x can be 5 also and x can be less than 5 also. So this is the solution set. Okay. And one more thing, in this question they did not ask you, but in your question they will ask you to show it on the number line. So this is a natural number line. It will begin with 1, 2, 3, 4, 5, and then one more extra. So we will be working. Okay. So this is how you have to even show it on the number line. If they ask you to show it on solution set on the number, usually they ask. Okay. Now the second sub question, 3x minus 2 is less than 19 minus 4x. This is the second sub question. So again, bring minus 4x this side, it will become plus 4x. 19 remains here. Minus 2 when you take it to the other side becomes plus 2. So 3x plus 4x is 7x is less than 19 plus 2 is 21. So implies x is, you are dividing by a positive number, so it will not change. Nothing, no reversal of the inequality because you are dividing by a positive number. Same thing here also. Here to get x, we divided by positive number 3. That is why no reversal of the inequality. So here also x is less than 21 upon 7. So implying x is less than 2. Now x belongs to natural numbers. So solution set will be 1, 2 because it cannot be 3 because it is less than 3. It can't be more than. And if it has to be shown on the number line, Okay, that is how it is. These are still lower level, but still one I will show you one more of your lower level only. Then we will go to your level question. This is your fourth question. All the sub questions are lower level, but this let me show you once for clarity. X minus 3 upon 2 is less than 3 upon 2 minus x. Okay, so this implies x minus x when it comes this side becomes plus x is less than 3 upon 2 minus 3 upon 2 when it goes that side becomes plus 3x. Okay, so this implies 2x is less than 3 plus 3 is 6, 6 upon 2. So implies 2x is less than 3. So implies x is less than 3 upon 2. So here whole x belongs to whole numbers is the question. Here x belongs to whole numbers. So whole numbers means 0 also is element. So implies x is equal to 0, 1, 2. This is less than 3 upon 2. Okay? No, 2 will not be there. Why? Because what is 3 upon 2? 3 upon 2 means 2 ones are 2, 1 and half. So it can't be 2. So 0 and 1 are the only elements of the solution set because it belongs to whole number. If x would have been belonging to natural numbers, then 0 also wouldn't have been there. And the solution set would have been just containing one element, 1. Okay? Now, let us do, this is your fifth question. This is simply a board question, very old board question, 1987. Solve the inequation 3 minus 2x is greater than or equal to x minus 12 given x belongs to natural numbers. Okay, so 3 minus 2x is greater than or equal to x minus 12. So we will bring x this side, plus x this side, and we will take plus 3 to the other side. So this implies minus 2x is already there, plus x comes this side, so becomes minus x, greater than or equal to minus 12 is already there, plus 3 goes to the other side, so it becomes minus 3. Okay, so minus 2x minus x is minus 3x greater than or equal to minus 15. Okay, now in order to get x you have to divide by minus 3. Okay, so whenever you divide by minus 3 or negative number, the inequality gets reversed. So in this case it will be implies x is less than or equal to minus 15 divided by minus 3. Understood? In order to get x, you have to divide by minus 3. So both sides you have to divide by minus 3. But whenever you divide by a negative number, the inequality sign gets reversed. That is the rule. So x is less than or equal to, greater than or equal to becomes less than or equal to, minus 15 is there, you are dividing by minus 3. So this implies x is less than or equal to plus 5 because minus divided by minus becomes plus 5. So the solution set we have 1, 2, 3, 4, 5 also included because it is less than or equal to. Okay? So in this question it did not ask you to show it on the number line. Now the next question is question 7. This is your third subquestion. It says 5 plus x upon 4 x upon 4 is greater than x upon 5 plus 9, and x belongs to R. Capital R means real number. So real numbers include every number, every fraction, negative number, integers, positive numbers, all are included in real numbers. Okay, so this is the equation. Okay, so implies we keep this x upon 4 here and bring x upon 5 this side and take 5 on the other side. So x upon 4 minus x upon 5 is greater than 9 minus 5. Understood? So this implies cross multiply 5x minus 4x upon 20 is greater than 9 minus 5 is 4. So this implies 5x minus 4x is x, x upon 20 is greater than 4. So if you multiply by 20 you will get x. 20 is a positive number, so x is equal to x is greater than 4 into 20. So implies x is greater than 8. So solution set is, you can write like this, you cannot write 1 to 80 numbers. So solution set is set of all x such that x belongs to numbers and x is greater than 80. That is the answer. Okay children, now let us do another question. This is also a board question, very old board question. Solve. The question 10. This came in the year 1990. 12 plus 1 5 upon 6 x is less than or equal to 5 plus 3x and x belongs to R, that is real number. Okay, 12 plus 1 5 upon 6x is less than or equal to 5 plus 3x, x belongs to real numbers, that is R. So let us write 12. Now 1 5 upon 6 becomes 6 ones are 6 plus 5 11, 11 upon 6 x less than or equal to 5 plus 3x. So we bring 3x this side and send 12 to the other side. So this implies 11 upon 6x minus 3x is less than or equal to 5 minus 12. Okay, so This implies cross multiply 11x minus 18x upon 6 into 1, that is 6, is less than or equal to minus 7. 5 minus 12. So this implies minus 7x upon 6 is less than or equal to minus 7. Okay. Now, in order to get x, you have to multiply it by minus 6 upon 7. Minus 6 upon 7. So the inequality will get reversed because you are multiplying by a negative number. So this becomes x, because we are multiplying by minus 6 upon 7. Minus into minus becomes plus, 6 gets cancelled. We are multiplying by the reciprocal, mind you, 7 upon 6. So we are multiplying by the reciprocal, 6 upon 7. So 1 it will become. So x, but since we are multiplying by a negative number, the inequality sign gets reversed. So it is less than or equal to, so it will become greater than or equal to, minus 7 is already there and you are multiplying by minus 6 upon 7. So 7 gets cancelled, minus into minus is plus, so x is greater than or equal to 6. So that means the solution set is set of all x such that x belongs to R and x is greater than or equal to 6. This x belongs to R, you can write this side also, that no, it makes no difference. And suppose you are asked to show it on the real number line. Now real number line, as I told you, has negative numbers as well as positive numbers, whole numbers as well as fractions, as well as decimal numbers. Okay, so you have to put the 0 in between. This side you have positive numbers, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. One more. Till 6 you have. Okay. It is greater than or equal to. So in fact, you must have more. Plus 8. Okay. And this side also minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. If you write plus 8 this side, you must write minus 8 also on the other side. Now here x is greater than or equal to 6. So values from 6 onwards. So you have to darken this or you have to hide it. But this will be infinite. So you cannot close it here. So that's why this arrow shows that it will continue. All the values on the other side are a solution set, belong to the solution set of this inequation. So you will not close this, it will continue. Okay, and you will darken this line. Okay, all the numbers that start from here. Is that clear? And you will make this, shade this, you will not keep this hollow. You will keep it hollow only when it is in inequality. Inequality means there is no equality sign. Either it is greater than or less than. Then this will be, this lollipop we call it, will be hollow. If it is along the inequality is accompanied by equality sign, then you must darken the lollipop. And also it is advisable, even if you darken the highlight the number line, it's okay, but sometimes children highlight it so faintly that teachers cannot make out whether you have highlighted or not. It is advisable you put shade this part. Okay. Now this type of inequation, this is your question 11, it has two inequalities. These are the type of questions that you often get nowadays in the boards with two inequalities. Until now we were having only one inequality sign. Now we have two inequality signs. Pay attention to my solving the question. It's very easy, but how to solve, just try to understand, then you can try to copy. Okay, the question says x belongs to I is integer. Find the solution set of minus 5 less than or equal to 2x minus 3 less than x plus 2. Okay, so there are two inequality signs, so you have to break it into two inequations. So you have to draw a line, and this is one part of the inequation, this is one part of the inequation, and this is another part. You have to break it into two parts. So the first part you will write here, minus 5 is less than or equal to 2x minus 3, and the other part is 2x minus 3 is less than x plus 2. Is that clear? There are two inequalities. When there are two inequalities, you have to make it into two inequations and solve it, and then club the answers. Okay. So first consider this. This implies minus 5 and minus 3 you bring this side, become plus 3 is less than or equal to 2x. So this implies minus 5 plus 3 is minus 2. Minus 5 plus 3 is minus 2. Minus 2 is less than or equal to 2x, implies minus 2 upon 2 is less than or equal to x. To divide both sides by plus 2. Since you are dividing by a positive number, the inequality sign does not get reversed. Okay, so this implies minus 1 is less than or equal to x. Okay, now let us come to this equation. Here 2x minus 3 is less than x plus 2. So bring this x on this side and take minus 3 on the other side. So this becomes, implies 2x minus x is less than 2 plus 3. So this implies x is less than 5. Okay. So now you will combine both the results. Here x is greater than or equal to minus 1 and x is less than 5. So x you write in between, or minus 1 is less than or equal to x, and thus x is less than 5. Okay, this is the combined forms. X is here greater than or equal to minus 1. So same x is greater than or equal to minus 1 and x is less than 5. So both you have combined. So now the solution set, x belongs to real numbers. So solution set will be set of all x such that minus 1 less than or equal to x less than 5, x belongs to real numbers. Now here they did not ask you to show it on the number line, but usually nowadays they ask you to show the solution set on the number line. They also say sometimes graph the solution set on the number line. Does not mean that you have to take a graph paper and draw it. You have to just draw the solution number line like this. Since it is real number, there will be positive numbers as well as negative numbers. So 0 in between. So here it is 5 is the maximum. So till 6 you will have to mark. So plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, and this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on. Okay, so x is greater than or equal to minus 1. So it is greater than or equal to sign is there. So the lollipop will be darkened. since equal to sign is there. Okay. Now this is only no equality sign. So x is less than 5. So here it will be hollow lollipop. Okay. And in between whatever numbers are there, the decimal numbers in between whatever numbers you have, all will be in the solution set. So you have to combine this and shade this. So this is how you have to represent it on the number line. Graphing the solution set on the number line means this only. You need not draw it on the graph paper. Okay, understood? Now let me go to the let me show you another question. Okay children, now this completes your 4A exercise. So you try solving the other questions which I haven't solved in your 4A exercise. That is 12th question, you can do it. I have done it till 4A 11. In between I haven't done some questions. Please solve them. And then I will continue with 4B in my next class.